Hello students, we shall begin our fourth unit, that is functions in C. So every C program has at least one function in it, and we have already been using some functions in C from the very beginning of our topic. So we will study this in formal detail in this unit. So what is a function? A function is a self-contained block of statements that perform some kind of task. So every C program can be thought of a collection of functions. Okay, so functions can be classified into two categories: library functions and user-defined functions. Okay. So what are library functions? Library functions are the inbuilt functions which are grouped together and stored in a common place called the library in the C compiler. Each library function in C performs a specific operation, and these library functions are created by the persons who designed and created C compilers and who still design and recreate the C compilers, update the things. Okay, so all C standard library functions are declared in many header files which are saved as some file name .h. Okay, and one of the most commonly used header file is that we have been using in every program is this stdio.h, that is the standard input output .h. Okay. So these functions can be used in our program as and when required by including the necessary header files. Okay, that is by writing #include filename.h at the beginning of a program. So some examples of library functions are given below. Functions in the header file stdio.h, they are library functions. So get character, we have already seen, it returns the next character typed on the keyboard. Put character, it outputs a single character to the screen. Printf, it is used for the formatted output. Scanf is used for accepting formatted input. Okay, all these functions are defined in the header file stdio.h. So since almost all C programs will require the use of at least printf and scanf, okay, so we need to include #include stdio.h in every C program. Okay, if we do not include, then and if we do not include and then if we use printf statement, the compiler will show you an error that unable to find the function printf. Okay. Another header file that we have already used is math.h. We have used the square root function defined in math.h. So the functions in the header file math.h are this. Several functions are there. Fabs, it returns the absolute value of the argument. Sqrt returns the square root of the positive argument, and sine returns the sine of the argument. Similarly, cos returns the cos of the argument. Okay, all these trigonometric functions. Inverse trigonometric functions. Okay, arc sine means inverse, sine inverse, right? Sin h, it will return the hyperbolic sine of the argument. Okay, that way. So there are several mathematical functions which are defined in the header file math.h. Okay, exp, it returns the exponential, that is e to the power x. Exp of x will return e to the power x. Okay, float function, it will return the greatest integer less than or equal to that given argument. Okay, then we have the logarithm, the power. So power function uses two parameters, so the arguments. So it returns, so if we write POW x comma 2, it will return x square. Okay, that way. Another header file that also we have used in the while discussing this do you want to continue type of statements in, say, writing C program using do while loop. We had used this function to upper, to lower. Okay. So to upper, it tests the character argument and converts it to uppercase if it is in lowercase, and to lower, this function tests the character argument and converts it to lowercase if it is in uppercase. Okay, so that way these three important header files we have already seen. So many functions are already defined there. Okay, however, it is not sufficient to use only the standard well-defined functions in C. In many of our programs, we may need to design our own functions. for our convenience. Okay, so that is why there is a provision for user defined function. So one user defined function that we always do in C is the main function. It is written by the user, that is by the programmer, right? So every C program must have a main function to indicate whether where the program has to begin its execution. So even though it is possible to write any program using only the main function, so till now we have whatever programs we have written so far, they were written only using the main function. Okay, so it leads to a number of problems. Okay, what are the problems? The problem may become too large and complicated, as a result of which the task of debugging, testing, and maintaining the program becomes difficult. Okay, what is debugging? Debugging is the process of finding out the errors in the program, right? So thus it is better to divide the program into a number of functional parts, each of which may be independently coded and later combined into a single unit. Okay, so there are many programs, maybe of thousands of lines. Okay, so it will be very difficult to deal with such programs. In that case, it is advisable to use separate functions inside the program to perform some specific task. Okay, so then even if there is an error, it is easy to find out which part has got an error. Okay, that is why the use of functions becomes important. These independently coded parts are called functions or user defined functions, right? So main is indeed a user defined function. So while other than main, how to define these functions? So following are the three elements related to a user defined function. One is a function definition. So a function is defined in the following format. So there is a type here. What is the type of the function? Whether it is integer, float, void, okay, like that, or character. So function type followed with a function name. Function name is a valid identifier name, right? And the parameter list. Okay, what are the arguments that will be used in the function? Okay, and within this function definition, this is the body of the function, right, where the task is defined, what the function will do. Okay, then there may be some local variable declaration. So local variables are the variables which are active only inside this particular function. They are not active outside this particular function. Okay, and an optional return statement. If the function type is void, then return statement is not necessary. If it is int, then we have to give some return statement, or if it's float, then also we have to give some return statements. Okay, so a function definition includes the following elements: function header, that is function type. It specifies the type of value that the function is expected to return to the program calling the function. It may be integer, character, float, etc. If the return function return type is not explicitly specified, then C will assume that it is an integer type function. Okay, so if the function is not required to return any value to the calling program, then the return type should be specified as void. Okay, we will see one example. There should be a function name. It is the name by which the function will be called in a program. The rules for naming a function are the same as the rules for naming identifiers in C. The name should preferably be appropriate to the task performed by the function. For example, if we are writing a function to calculate the factorial of a number, okay, then we may name the function as fact or factorial. Okay, so it should be related in some way, so that it's easier for us to program the or write the code. Okay, suppose we are writing a function which adds two numbers, so it's meaningless to name the function as subtract. Okay, because the function performs the work of addition. Even though if we write subtract as a name of the function, it will do the same purpose as that addition. It depends on how you write the body, but it doesn't make any sense. If you are writing a function to add two numbers, it's always better to name it as add or sum, okay, instead of difference, right? So, and the third part that is there is the formal parameter list. The parameter list declares the variables that will receive the data sent by the calling program. Okay, they serve as input to the function to carry out the specified task. Okay, these parameters are also known as arguments. Okay, right. Okay. Okay, so just before proceeding further, let us have a look at one such functions that we will see. Okay, in this one, okay, we will write this program. Yeah, so this is a program to add two numbers using a function. Okay, suppose I want to add two numbers using this function. So what is this? Hash include stdio.h int add int. So int is the type of the function, the return type of the function. Add is the name of the function, and then here int and int they represent the type of parameters that will be used in the function. Okay, so this is something called function prototype declaration. We will come to it after some time. Yeah, this one, function prototype declaration. Okay, we'll come to this. So let us see this. So this is the function that we have defined here, and this is the main function. So what does it do? It declares to the main function. We declare two variables x and y, then we take them as input, and then we find out the sum. But we do not find out the sum in the usual way, that writing x plus y. Instead of that, what we do, we call this function add xy. So this expression is actually the expression for calling the function. Okay, this expression is actually the function call. Okay, we call the function at this position. So we want to add the numbers x and y using the function definition here. Okay, so this is the one, add xy. So once this program encounters this function call, it will come to this function definition. It will search for the function definition. Yeah, so here is the function definition. It will come to this place. Okay, it will come to this place, and it will see how the function works. So int add int a int b. So you observe that here we have not used x and y, right? But what is happening, the value of x will pass into this a, and the value of y, it will pass into the second argument. Okay, so that is always in the respective manner. The value of the first argument is passed to the first argument in this function definition. Value of the second argument is passed to the value of the to the second argument in the function definition. Okay, so what is the work of this function? The job of this function is to return a plus b. Okay, so when we call add xy, the values of xy will be passed to this function, and a will take the value of x, b will take the value of y, and this function will return the value a plus b. So a plus b will be returned by this, where at the position where it was called. So it was called at this position, so the value of the function will be returned at this position only. Okay, so this is how this will work, function will work. Okay, so this is what we have written. Function body, local variables declaration. So the local variables that we have used here are yeah, we have not used any local variables inside the function. So in the next program we will see that we will use. So there, if some variables are required inside the function, then we will define them as local variables. Okay, their scope will be visible only inside the body of the function. Then the function statements, these are executable statements which are written as per the requirements of the programmer, right? And the return statement, it returns the value evaluated with the function. If a function is of void type, then the return statement can be omitted. Okay, so function call, in order to use a user defined function, we need to call the function in the program where it is to be used. Okay, in general in the main function. So a function can be called by simply using the function name followed by a list of actual parameters, if any, enclosed in parentheses. Okay, the actual parameters in the function call must match the arguments, the function's formal parameters in type, order, and number. Okay, the multiple actual parameters must be separated by commas. Okay, so here already we have seen the actual parameters. There are two actual parameters here, so they are separated by commas. Okay, right? So in the function call, the parameters that we use are called actual parameters, right? So the type, order and number of the actual parameter should match with the type, order and number of the formal parameters in the function definition. Okay. So the function prototype declaration is like variables. All functions in C must be declared before they are invoked. Okay. So the general format of a function prototype declaration is. So what is the general format of a function prototype declaration? It is function type, then function name, and the list of parameters. Okay. So this is what we have seen in the very first line of this program. This one, this is the function prototype declaration. Okay. So it's return type, the name of the function, and the list of parameters. Okay, but one thing you observe here, I have not written any variable. It is just sufficient in the function prototype. It is just sufficient to mention the type of the variables. Okay, the names of the variables are not necessary. Okay, so thus a function prototype declaration consists of 4 parts. One is function type, another one is function name, then the list of parameters, and then a terminating semicolon, right? So it is to be noted that the parameter names do not need to be the same in the prototype declaration and the function definition. Okay, only the types of the parameters in the prototype must match with those in the function definition. Okay, both in number and order. So if we write int comma float in the function prototype declaration, then in the definition also we have to maintain this order, int x comma float y. Okay, so it is not even necessary to use parameter names in the function prototype declaration, but it is sufficient to use only the types of the parameters. So a function prototype declaration may be placed in 2 places in a program, above all the functions, that is including the main function. In this case, the prototype is referred to as a global prototype. Such declaration mean that the function can be used anywhere in the program. Okay, and another way of declaring a function prototype is inside another function. So when we place a function prototype inside the definition of another function, then this function can be used only by the function containing it. We cannot use it outside that particular function. Okay, so there are 2 ways of declaring function prototypes. Then there is recursion. We will come to recursion later. Now we are not discussing. We will let us see some examples of using functions. Okay, so let us open this terminal. This is the terminal. Let's see this file. Program number 37. Yeah, this was the program. Okay, program to add 2 numbers using a function. Okay, so int add int, right? Void main, then int xy, printf enter the 2 numbers, printf scanf %d %e %x %y, printf the sum of the numbers is add xy. Okay, so this is the function call, and then this function will return the value of a plus b. Okay, so let us see how this works. So it's / program 37 function. Okay, enter the 2 numbers, say 5 and 8. The sum of the numbers is 13. Okay, this is how it works. 2 1, the sum of the numbers is 3. Okay, so this is 1. Okay, now the same program we may write it in a different way. Instead of using the int as the return type, we can use a void as the return type, and then we can write the same program to add 2 numbers using a void function. So instead of using int as the return type, we now use void. That is, the function will not return any value, but even then it will perform the task of adding the 2 numbers. So this initial portions are same, but you see here in the main function I have not given any printf statement. I have just called the function add xy. After taking the input as x and y, we will call this function add xy. Now what does this function do? This function doesn't return any value to the main function, but see what it does is it will just print, it will write that the sum of the numbers equal to %d a plus b. Okay, it will give you this as the output itself directly. So it's not returning any value to the main function, but it is serving our purpose. Okay, it is serving our purpose. So the same program can be written this way also, by using void as the function return type. Okay, say 5 6, the sum of the numbers is 11. Okay, the values are not being returned, they are computed inside the add function, and they are printed also inside the add function only. Okay, so this is another one. Let us see another program, say program to find NPR and NCR by defining the factorial function. Okay, suppose we want to find out the NPR, the number of permutations of n objects taken r at a time, and number of combinations of n objects taken r at a time. Okay, so for this we need to define the factorial function. So since factorials are very large numbers, instead of taking int, we can take this one as long int. Okay, so the return type of this function will be long int fact, and it will take only one argument, so it's only int. Okay, so in the main function we will define two variables n and r. We will take their input. Okay, and then we will print. NPR is what? NPR is so %ld, this is the format specifier for long int. Okay, so it will print the value factorial n by factorial n minus r. That is the formula for NPR, as we know. Okay, and NCR equal to factorial n divided by factorial n minus r into factorial r. Okay, so from this program you can see what is the importance of defining functions. Okay, it may be necessary to compute a loop sort of thing several times in the same program. So instead of writing the same loop several times, we can just define that loop inside another function and get those values. So here say factorial n. To find factorial n, we need this for loop, right? This for loop is required for finding out the factorial n. So if we do not define this as a function here, then every time for factorial n we need one for loop. For factorial n minus r, we will need another for loop inside the same function. For factorial r, we will need another for loop inside the same function. Okay, and it will become very complicated, right? So it is better to, since we are using the same concept here, factorial finding factorial 3 times, so it's better to define the factorial function itself here. So factorial is not inbuilt in the C compiler, so we have to define it ourselves. So it is a long int type of function, so we define it this way: long int f equal to 1, int I is the counter variable here. So if n is non-zero, then we compute this f is equal to f star I. For I equal to 1, I less than or equal to n, I plus plus, f equal to f star I. This will give you the value of the factorial and ultimately return f. So if n is 0, what will happen? It will just return f. What is the initial value of f? Initial value of f is 1. So if n is 0, it will just return 1. We know factorial 0 is 1. Okay, so that is how this program is working. So let us see. / program 39. Enter n, suppose 5. Enter r. So 5p2 is 20. 5c2 is 10. Okay, so we can write it this way. So if you want a better output of this, so we may write it this way: %d cr, instead of r we write %d, and then here we write n comma r, and then this. Okay, so let us see how this looks like. Enter n, say 5 2, see NPR is 20 and 5c2 is 10. Okay, so we can format our output that way, right? So let us see another program here, 40, to program to illustrate formal parameters and actual parameters. Okay, so we have seen that we are passing the values of the variables to the function. So is the pass affecting the variables in any way? Okay, when we pass the values of x and y to this function, whether the values of x and y are affected in the original function. Okay, so for that I have written a simple illustration. Say we entered some x and y, and we have defined one variable change, function change. So what does it do? It doesn't return any value, but it makes the value of x as 6 and makes the value of y as 9. So we may think that the variables x and y here, initially suppose we take them as different from 6 and 9. So we will print those values here before calling the function. X is this, y is this. Then we call this function change xy. So it seems that the value of x will now become 6 after we call the function, and y will become 9. Okay, but let us see what will happen. So after calling the function, we may expect that the value of x becomes 6 here, value of y becomes 9 here. Let us see whether this is actually the case. Okay, so this is the program number 40. Suppose enter x is 7 and y is 0. So before calling the function, x is 7, y is 0. After calling the function also, value of x is 0, 7 is x is 7, y is 0. Okay, say 3 and 5. So before calling also it's 3 5, after calling also it's 3 5. And that means what? The change of the variables inside this function is not affecting the change in the original variables here. Okay, why is this so? Because when we pass the values of the variables to a function, only the copies are passed. So a copy of x is passed to this formal parameter x, a copy of y is passed to the formal parameter y. Okay, so the original values of this actual arguments, they remain intact. Even if we change this x y here, it will not make any change in the original variable. Okay, they will remain as same, right? So we will also see in the next lecture how we can modify the actual parameters as well. So that will require the use of pointer. Okay, and that will require use of pointer. So we will see. So as of now, we understand that the passing the values of the actual parameters to the function does not change the values in the main function. Okay, values will not be changed. Okay, whatever changes you make. That is why the name of the formal parameters may be different from x and y. Okay, we can write something like a and b also, no problem. And in fact, we had seen in the earlier program the value of the formal parameter, the parameter list of the formal parameters and the actual parameters may not be same, but they should be same in order, they should be same in the type. Okay, right? So this was about functions. Okay, so in the next lecture we will see some more functions, examples of functions, and then recursive function. What do you mean by recursion? We will see that also. So